Welcome to A Quick Jump. I'm Rich Bowers, and with me is Charles Dunn. Charles, I had to bring you in for this. Me and you are both big gaming fans. And the past few weeks, I know you noticed large language models are being compared to each other through competing in video games. So you may have seen Mario, the original, with Claude, ChatGPT, and Gemini competing with each other to see who can get to level 2. Or maybe even who could become a Pokemon training master. It's been really interesting, but my question to you to kick off here is, what are your thoughts? What is the validity into these type of benchmarks, as they're now calling them?
So, I think this is interesting. This is very interesting. It is, how well can a system designed to interpret language understand the language of video games? So it is an interesting way to study side effects or second order abilities of language models, of reasoning models. But I am of the opinion this is not a very useful benchmark. This is not a very useful technical benchmark. This is a curiosity, an interesting curiosity, but it's not really going to be indicative of performance in a technical capacity, because video games are designed to evoke emotions in humans. Video games are designed for a human audience to experience human feelings of accomplishment, of challenge, and so on. And there's a lot of ways that video games obfuscate their mechanics to facilitate this. In platformers like Mario, there's often what developers call coyote time, where you can still perform a jump even if you didn't land on the platform correctly, like Wile E. Coyote from the Roadrunner cartoons. Mm-hmm. And this is to make it feel better when you miss a jump. It's to facilitate human feeling, but the language model only understands the mechanics. It doesn't understand the feeling that it's trying to evoke. It's only going to understand, okay, the actual place where I could jump off is more than the visual representation of the platform. So it's going to see more the nuts and bolts of the mechanics rather than understand what the video game is going for, what it's trying to evoke. So I don't think they're good benchmarks for technical performance, but it is interesting to see how well it can interpret its vision reasoning and things like that.
I knew I brought the right person on for this discussion. So, okay, a couple quick follow-up questions there. So then overall, what you're saying is that this is kind of just maybe fun advertising as opposed to really seeing that, hey, you know what? Claude is a stronger model than ChatGPT because they were able to catch them all in the Pokemon game.
Exactly. Like, a model is going to see through all of those deliberately programmed hidden mechanics. It's not going to tell you much about its performance.
Let's take a quick look at benchmarks.
Yes.
What do they usually provide marks in?
So, to keep it very short, benchmarks are a standard set of inputs, and you're testing how well the model is able to perform a pre-programmed set of reasoning tasks. Now, these could be language and reasoning, multimodal benchmarks. There's a whole bunch of them, because really these models are going to be optimized to do different things. Are they going to be optimized to distill information? Are they optimized to make new reasoning calculations? Things like that. And now there is some skepticism, and you can count me among these, over whether or not these benchmarks are actually, whether benchmarks in general are actually meaningful. Because a lot of the benchmarks have, standard inputs. You have to have standardized inputs and standardized expected outputs in order for these benchmarks to be useful at all. And at a certain point, the models, well, they might even have the benchmarks in the training set. So the fact that these benchmarks are standardized may be contributing to models overperforming on benchmarks and underperforming in actual practice.
That is a fantastic point that I have not heard before, but makes perfect sense, especially through our discussions previously on the way training data is actually collected and trained on. So there is a chance that you're saying these standardized tests, they're basically already given somewhat of the answers, and that's why you constantly see these improvements. Yes, we're not saying the models are not stronger or there's not improvements, but frankly, if you know some of the test answers to start, your grades are going to be higher.
Yeah, that's a good way to put it. Like, it's often been a complaint of standardized tests for humans that a standardized test is a test of how well you take the test, not of how well you're going to perform in college.
Yes, that's right. And I am a prime example of that. So my last question then for you is, the games that we are seeing for the benchmarks are like from the 80s and 90s. Would there be a difference if they were comparing the models, probably not there at the moment, but say beating an Elden Ring boss, a very new game?
The reason why they're usually competing on these simpler games is, well, it's twofold. The target audience of these are people who, the people who make the models want to get hyped about them, and those people are probably more familiar with Super Mario Brothers than they are with Elden Ring. So just to be blunt here about what these demos are actually for. It's
a little advertising.
It's a little advertising. And the other thing is that older games have simpler presentation. It's like, just by the nature of what the older hardware could render, if you have a vision model, there's less to see. There's less to discern about from Super Mario Brothers than there is for Elden Ring. There's also probably a lot more training data on Mario Brothers than there is on Elden Ring. Earlier, there was an example of a real-time generated game. They said a game can be generated on the fly without a game engine, and it was Minecraft. And they used Minecraft as an example because there's so much Minecraft footage out there. There's hours and hours and years of Minecraft Let's Plays, so there's enough content out there for the model to just generate what it assumes the next thing in Minecraft is going to be. So playing a game like Mario Brothers, where there's a ton of training data already, is probably easier for a model that works on prediction than a brand new game with a ton of visual information that it has to interpret in real time.
That is a lot of information I have never thought about, and you are so spot on. Just getting to the direct point, though. So you're saying then there could be a value in benchmark if they're playing against, say, Elden Ring or Elder Scrolls or whatever it may be.
It will be interesting in two ways. Interesting to see how the model performs, and interesting for the engineers who are making them. How would the inputs be sent to the model? Would the model be watching the screen? Or would the model have some kind of access to the back-end rendering? Could the model perform better if it understands more of what's going on? And then it would be a question of how well can a model interact with a complex system that it has access to, which might be more indicative of a real-world use case of models, which could be like monitoring these complex systems. Because I hope we're not at a point in society where we want a language model to play video games for us. We can have the models do all of the video games for us while we focus on the real stuff of society. our jobs.
You gave me so much to think about, and I hope everybody listening as well, and totally different perspectives than what is typically fed to us on this. So I'll let you get back to work, Mr. Dunn. I appreciate your time. For The Jump, I'm Rich Bowers. Take care, everybody.